Today we are going to discuss about integration, which is inverse process of differentiation. Example, suppose differentiation of a function 1 is nothing but x to the power 0, or you can look for what function I should differentiate to get 1. We know that differentiation of x will be 1. That implies integration of 1 will be x plus constant. Second rule is, so these are basically rules of integration that you should remember. This is first rule. Second rule is, suppose you have a function multiplied with a constant under integral sign and you are integrating with respect to x. Then you can take c outside and integrate fx with respect to x. Let's say so some sort of constant multiple. You can take constant outside the integral sign. Third rule of integration is equivalent to sum or difference rule. Suppose you have two functions fx plus gx integrated with respect to x, then this is equivalent to integrating fx with respect to x plus integration of gx with respect to x. So if there is a sum, then you can split the integration into two parts. If there is a minus sign over here, then you can write fx minus gx will be integration of fx dx minus integration of gx dx. Let's try to understand these rules through examples. Suppose we have an integration of x square plus x plus 1 function to be integrated with respect to x. Then you can apply some rule here that this will be equal to integration of x square with respect to x plus integration of x with respect to x plus integration of 1 with respect to x. Now you can use the formula for integration of that integration of x to the power n dx is nothing but x to the power n plus 1 divided by n plus 1. So you can use this here and you can write the next step that this would be equal to x to the power 2 plus 1 3 divided by 3 plus here x to the power 1, so 1 plus 1 divided by 1 plus 1, so it will become x to the power 2 divided by 2, and this is integration of dx, then differentiation of x is 1, that implies 1 dx will be x itself. And there will be 3 integration constant that will appear, and you can simply write one constant. It's not a big deal. Let's take another example. Now we have to integrate 4 sin x plus cos x with respect to x. Then this can be evaluated as integration of 4 sin x with respect to x plus integration of cos x with respect to x, and you know that 4 is a constant. You can take it outside the integral sign in the next step, and you can write 4 integration of sin x dx plus integration of cos x dx, and you can use the formula now that differentiation of minus cos x will give you sin x. So answer is minus 4 cos x for the first integral. Then cos x integration will be sin x. You have to remember the formula plus constant. Let's see another example. This time we have to suppose integrate x plus 1 by x dx. Then this can be further evaluated in terms of integration of x dx using sum rule plus integration of 1 by x with respect to x, 1 by x dx. And x dx integration will be x square by 2 using x to the power n plus 1 divided by n plus 1. Here you cannot apply x raised to the power minus 1 plus 1 divided by minus 1 plus 1 because for n equal to minus 1 the integration is for log x because 1 by x comes from the differentiation of log x. So you have to remember this, that it will be log of x plus constant or ln x plus constant. So be careful with 1 by x. Now we'll study fourth rule of integration, which is an important rule. It is called substitution rule. It says if you have an integration of a composite function, of a complex function, in which you put substitution u and you get the function as of u, and there is a term in the product of the function which is differentiation of u with respect to x, and then the differential variable dx, then this can be written as integration of fu du. So you can see here dx for the sake of understanding, we cancel out and we will have du. So this can be written as fu du. So the integration that you are carrying out in x can be converted into u, that the differential variable is u and the function is also of u. For example, suppose we have a function sin x into cos x dx. It's a product of sin x to cos x. You can clearly see if I put a substitution u here, that u equal to sin x, then differentiation of u with respect to x will be cos x, and this is equal to du by dx. So this integral can be converted into du. Let's see how it can be done. So we'll say, let's substitute. Let's u be sin x, then du by dx will be cos x, then you cross multiply, then you will get du is equal to nothing but cos x into dx. If you can see clearly, you will observe that I can substitute sin x with u, and I can substitute cos x dx with du. So what happens to this integral? Over here, sin x will be converted into u and cos x dx will be du. So here you can write this integration is simply u for sin x and cos x dx is du. You can write u du. That integration will be very simple in u, and it can be written as u square by 2 plus some constant. Then you can back substitute u for sin x. We have sin x squared divided by 2 plus constant. Let us see another example. Suppose we have to integrate x square plus 1 raised to the power 5 and then x dx. Then you can see this integral will be much simpler in some other variable u if I put x square plus 1 equal to u, because u to the power 5 integration can be done. You don't know the formula for this, it would be much easier in u. Let's see what happens if I put that substitution. X square plus 1 differentiation will be 2x. So we have an x term over here. So it can be converted into this form. So let's say we have u equal to x square plus 1. then this integration will be starting to convert into u, and the first term will become u to the power 5. Now let's see what x dx can be substituted for. How can we convert dx into du? Now look at this. If you differentiate u with respect to x, you will get 2x. If you cross multiply, you can quite clearly see that du by 2 is equal to x dx. So, a clean observation will tell you that x dx here can be substituted for du by 2. So, the next step is substituting x dx with du by 2. We have du by 2 here, and 2 is a constant. So constant can be taken outside. So 1 by 2 can be taken outside, and you will have u to the power 5 d. Now the integration is much simpler and will be converted to u. So 1 by 2 u to the power 5 plus 1 divided by 5 plus 1, because it is integrated with respect to u. It will become u to the power 6 divided by 6 plus. Let's see another example. Much simpler one. Suppose I have to integrate sine kx with respect to x, where k is constant. Now obviously we don't have formula for sine kx. We know the integration of sine x, which is minus cos x, but we don't know the formula for sine kx. So what we can do here is apply substitution rule. We can put kx equal to u equal to kx, and you will get du by dx is nothing but d by dx of kx, which will be k taken outside, d by dx of x, which will be 1. So here you will get k only. And you can cross multiply and check that du by k is equal to dx. So this integral here, sin kx can be substituted for sin u, and dx can be substituted for du by k. So this integration will be sin u du by k. K can be taken outside, as we have already said it's constant. Then integration of sin u will be with respect to u is minus cos u plus constant. Then you can back substitute u, and you will see it will become minus cos u is kx divided by k plus constant. Now suppose we have to integrate root of x square plus x into 2x plus 1 dx. Now this is a complicated integration, and you should look for substitution. The obvious substitution here is x square plus x. If you try u is equal to x square plus x, then this first term will convert into root u, which will be easier to integrate with respect to u, only if 2x plus 1 dx converts into du. Let's see, du by dx is 2x, u is equal to, it is x over here, u is x square plus x. So now this will become 2x plus 1, and you can see du is equal to 2x plus 1 dx. So this term is du, and this term is root of u. So the integration in u will be much simpler. This root u is u to the power half, u to the power half plus 1 divided by half plus 1. You will get u to the power